Ever feel like developing software is like playing whack-a-mole? You get rid of one bug and like two more just pop up.
Yeah.
And today we're diving deep into how to stay ahead of all those bugs with smarter testing.
That's right. It's not about, just throwing a bunch of tests at a problem.
Right.
It's more about designing your tests strategically to make sure they're really effective.
So let's talk about this whole idea of test case design.
Okay.
What is it? And why is it so important when you're developing software?
Well, imagine you've built this amazing app with all these cool features, testing every single possible input. That would be a nightmare.
Sure.
So test case design is about picking which scenarios to test and making sure that you're catching the most bugs without wasting time on checks that are just repetitive.
That makes a lot of sense.
It's all about efficiency and effectiveness.
Okay, so what are some of the techniques that we can use to design these tests in a smart way?
Two of the most popular and powerful techniques are equivalence partitioning and boundary value analysis.
Oh, okay. Those sound a little technical.
Yeah, they do.
Could you break it down for us?
Sure.
What's equivalence partitioning all about?
So imagine you're building a login system, right?
Oh, right.
And you've got this rule that passwords have to be at least 8 characters long.
Right.
So equivalence partitioning basically says divide up all the possible passwords into 2 groups.
Okay.
You've got your valid passwords. Those are 8 characters or more. And then you have your invalid passwords less than 8 characters.
Got it.
And then you just test one password from each group.
Oh, okay.
The idea is that if one password in a group works or doesn't work, the others in that group will probably behave the same way.
That's actually pretty intuitive when you think about it.
Yeah.
So instead of testing like a million different passwords,
right,
you're just choosing a few that represent each category.
Exactly. And this can really dramatically reduce the number of tests you need to run, which saves time and resources.
So that's equivalence partitioning.
Yes.
So where does boundary value analysis fit in with this?
So equivalence partitioning covers the general cases, but boundary value analysis is all about those edge cases, those places where things are more likely to break.
I see.
So going back to our password example, we would test what happens when someone enters a password with exactly 7 characters, 8 characters, and 9 characters.
Oh, because those are right on the edge of the rule.
Exactly.
It's where the system's behavior might suddenly change.
Yes, it's like testing the fence, not just the field. Systems often have little quirks or glitches at those boundaries.
Right.
So it's really important to pay close attention to those areas.
So equivalence partitioning helps us cover the broad strokes, and then boundary value analysis zooms in on those critical edges.
You got it.
It sounds like these techniques aren't just about finding the bugs, but they're also about building confidence that the system's actually going to be reliable.
Exactly. By using these techniques, you can significantly increase the chances of catching those tricky bugs early on.
Right.
Which means you're ultimately creating higher quality software.
Okay, so we've got equivalence partitioning and boundary value analysis down.
Yes.
Are those the only tools that we have for designing test cases, or is there more?
Oh, there's a whole world of techniques out there, each with its own strengths.
Okay.
For example, have you ever worked with code that has tons of if this then that logic?
Oh, yeah.
So for those situations, decision table testing is like your new best friend.
Oh, okay. I'm interested. How does that one work?
Let's say you're building an e-commerce site with a really complicated discount system.
Okay.
The discount might depend on the customer's loyalty level and how much they're spending.
Right.
Decision table testing helps you map out every single combination of those factors and what the discount should be for each one.
So it's like a cheat sheet to make sure that the discount is always calculated correctly.
Yes, exactly. It's a really powerful way to make sure your code behaves the way it's supposed to in every possible scenario.
That's super helpful, especially when you've got lots of moving parts.
Yeah.
So what other techniques should we know about?
Another interesting one is state transition testing. And this is perfect for systems that change their behavior based on their current state.
Okay, I think I remember you mentioning that one before. Can you give us an example of how that might work in the real world?
Sure. Think of a music streaming app like Spotify.
Okay.
It has different states like playing, paused, shuffling.
Right.
So state transition testing makes sure that moving between these states always works smoothly no matter what the user does.
So if I'm listening to a song and then I hit pause and then hit play again, state transition testing would make sure that the app handles all of that correctly.
Exactly. It's all about making sure that the app responds the right way to every possible change in state.
This is making me realize that there's so much more to designing effective tests than I thought. It's not just about like randomly clicking around and hoping for the best.
Absolutely. There's a real strategy and a science to it.
Yeah.
And the more you understand these techniques, the better you'll be at building software that's not only functional, but also really robust and reliable.
So it's like we're peeling back the layers on this, and there's like a whole lot of complexity to software testing.
Yeah.
And these techniques are super helpful. But how do we actually like put them into practice?
Right.
Let's say I'm building a simple contact form for a website.
Okay.
How would I use something like equivalence partitioning for that?
Okay, so let's say your contact form has a field for the user's email address.
Right.
With equivalence partitioning, you'd think about all the possible things that someone could type in there
Okay.
and group them into categories.
Got it.
So you'd have like a group for valid email addresses like user@example.com.
Right.
And then a group for invalid email addresses like maybe they're missing the @ symbol or something.
Okay.
And then maybe even a group for those weird edge cases, like really, really long email addresses.
So I wouldn't have to test every single email address I could think of.
No, you just pick like one from each group.
I see.
You're basically focusing your testing on the areas where you're most likely to find bugs. And you're also thinking about the boundaries between those groups, which is where boundary value analysis comes in.
Okay, so with boundary value analysis, I might test an email address that's right at the limit of how long it's allowed to be,
Yeah,
or one that's just one character away from being valid.
exactly. You're trying to see if the system breaks at those points.
Right.
What's really cool is that you're not just guessing randomly. You're using like a system to make sure you're covering the most important scenarios.
I'm starting to see how these techniques can really make testing a lot more efficient.
Yeah.
But what about those more advanced techniques we were talking about earlier?
Yeah.
Like decision table testing and state transition testing. When would we use those?
Okay, so imagine you're building an online shopping cart.
Okay.
And the shipping cost depends on a bunch of different things, like the customer's location, how heavy the items are, whether they have a promo code and all that.
Right, that can get complicated.
Yeah, so decision table testing would help you map out all those combinations and make sure the shipping cost is always calculated, right?
So it's like a giant spreadsheet with every possible scenario.
Pretty much. It's a great way to make sure you're handling all those variables correctly.
Okay. And what about state transition testing?
Right, so remember, that's useful for systems that have different states.
Yeah.
Let's say you're building a game, like a puzzle game,
Okay.
and the user has to solve a bunch of challenges to move forward. Each challenge would be like a different state.
I see.
So state transition testing would help you make sure that the game flows smoothly from one challenge to the next.
So you're making sure there aren't any weird glitches or anything that blocks the user.
Exactly.
Mm-hmm.
It's all about making sure that everything works the way it should from the user's perspective.
This is really interesting. I'm starting to see how we could use all these techniques for different kinds of software.
Yeah, for sure.
From simple things like contact forms to complicated things like games.
Absolutely.
It's making me think differently about how I approach testing in my own work.
And that's great because these techniques aren't just for people who do testing professionally. They're valuable for anyone who's involved in making software.
So it doesn't matter if you're a developer, a product manager, or a designer.
Exactly.
Understanding these techniques can help everyone build better software.
Yeah, it's all about thinking critically about how your work will be tested and making it as easy and effective as possible.
It's like you're giving everyone the ability to, like, see where those bugs might be hiding
That's a good way to put it.
and get rid of them before they cause any problems.
Yeah, and the more you use these techniques, the easier they get. You start to see patterns and you can kind of anticipate where the problems might be.
So it's not just about finding the bugs, it's about stopping them from happening in the first place.
Exactly.
This has been a really great conversation.
Yeah.
It's like we've uncovered this whole secret language of testing.
It is kind of like a language, and the more you practice, the better you get.
So for our listeners who are like ready to take their testing skills to the next level, where should they start?
I would say start small, pick one technique that you think might be useful, and try it out on a small project.
Okay.
And don't be afraid to experiment and see what works for you.
Sounds like the hardest part is just like taking that first step.
I think so, yeah. Once you start experimenting, it's not as scary as it seems.
Right.
And you don't have to figure it all out on your own.
True.
There are so many resources out there, like books and articles and even online communities where you can connect with other people who are doing testing. You can share what you've learned and get advice and stuff.
It's like a whole community of bug hunters.
Yeah, exactly. All working together to make better software.
I like that. So it's not like there's just one right way to do testing.
No, not at all.
It depends on the project and the team.
Exactly. What works in one situation might not work in another.
Okay.
You have to be flexible and creative and always willing to try new things.
So it's all about like adapting and learning and getting better over time.
Exactly. Testing is a journey. It's not like you just arrive at the destination and you're done.
Right.
There's always something new to learn and new challenges to face.
Well, this deep dive has been super helpful.
Good.
We've gone from feeling overwhelmed by testing to feeling like we have a bunch of tools to make it more manageable and more effective.
And hopefully a little more fun too, because really testing is about more than just finding bugs.
Right.
It's about making sure the software we build is actually enjoyable to use.
It's about making those experiences smooth and intuitive and frustration-free.
Exactly.
I like that. So as we wrap up here, I want to leave you with this thought.
Okay.
Imagine you're building a bridge.
Okay.
You wouldn't just build it and hope it stays upright.
No way.
You test every part of it really carefully and make sure it can handle all the stress.
Of course.
Software's kind of like a bridge, too. It needs a strong foundation, and it has to be built well and tested thoroughly to make sure it can do what it's supposed to do.
I like that analogy.
And with these techniques we've talked about today, you have what you need to be those careful builders.
Yeah.
The ones who make sure the software works perfectly.
Exactly.
And who knows, maybe you'll even start to enjoy testing.
It seemed to be pretty satisfying to find those hidden bugs.
Right.
Knowing that you've made the software just a little bit better.
So to all our listeners out there, go build some amazing software.
Have fun testing.